Internet Technology Lab, basic BGP configuration. You might remember me saying in another nugget that this was the last topic that I thought Cisco would add to the CCNA curriculum, but they did, and so here we are. But the way that Cisco added it was very basic, meaning BGP, as I mentioned before as well, is an entire series at CBT Nuggets. If you really want to dive deep into BGP and it interests you, you're interested in going into the service provider realm, I definitely encourage you to look through that series. At the CCNA level, Cisco is saying, we just want you to know how to form a neighbor relationship between these two routers running BGP and advertise a network out into the internet. As you're likely accustomed to, I'll probably go a little beyond the exam objectives and give you some bonus BGP information, but it'll be so good. It'll be like that second teaspoon of peanut butter. Love peanut butter. The Max Corporation has decided to bring up redundant connectivity for their corporate office, there it is, to ensure their email and web hosting services are resilient should the connection to their primary ISP fail. They would like to test BGP with their primary ISP, that'd be these guys right here, before entering into a long-term agreement with a secondary service provider. So they're looking for a proof of concept. Does this work? So here's our objectives. First off, configure BGP for the Max organization in Autonomous System 5000. So we become a cloud on the internet in Autonomous System 5000. Now, how did they get that autonomous system? Likely, if you're in the United States, you went to ARIN, the American Registry for Internet Numbers. I believe it's ARIN.net, and you actually register for one. You can do that. You can even get blocks of IP addresses in the IPv6 space, because that's the one that's not there. If you're ever up for an adventure, I encourage you to go there, and you'll probably want to stop when I get to the point where they say, give us $500 a year plus $1,000 a year for maintenance, and so it costs money to do that, right? So establish a neighbor relationship between the Max and ISP routers. The ISP is running in Autonomous System 2500. There they land. Confirm the Max router is receiving BGP routes. So build that neighbor relationship. Make sure it's getting the BGP routes from the ISP, right? Then advertise this network owned by Max. So they own this public space right here via BGP to the ISP router. This is my above and beyond. Also, let's advertise a summary route. So let's say they not only own this one, but let's advertise as though they own 63.2.0.0/16, right? And maybe the Max Corporation do. There are a lot of places, especially college universities, that own huge amounts of IPv4 address space. And so you do run into these places that have these kind of blocks. Now, chances are good they've probably taken that and subnetted that into all their other offices. You know, over here is another router that connects to, branch office A and B and whatever else the topology ends up looking like, right? But we can summarize all of those into one big advertisement that we send out. I'm going to show you how to do that to the ISP. Keep in mind, a real ISP also has to play in this game as well. And this is where they would put filters up. They're very careful to make sure that you only advertise addresses that they know that you have, right? So they will put a filter on, and you'll tell them, hey, I own 6315, and they will say, we will only allow you to advertise just that. Otherwise, they open themselves up to sabotage, right? Because you could say, I own the world, right? And point to that ISP, and they would go, wow, you're right next to me. Well, let's point all of our routing out to that customer for them to reach the world, and you start dropping all of the ISP's traffic, right? Because you don't really have the world. So that's the kind of filters that I'm talking about. Now, I feel you. I feel questions as I talk and I do these things. Someone might say, well, why would I run BGP in this situation anyway? I mean, help me understand, Jeremy. We're bringing up the secondary ISP, right? There's ISP2, right? And there's their little cloud. These guys are Autonomous System 2500. Maybe these guys will be 2501 or something like that. And we bring it in right here. So the question, Jeremy, why am I running BGP when they could just point to me with a static route, right? And say that's, I've got that connection. And that's actually what a lot of ISPs do, is they will point to you and just say, here, I've got the static route, and then they redistribute that static route to the rest of the internet so that they do. Why do we need BGP? There are many reasons, but I'll give you two big ones. First off, BGP is alive, meaning it's a live protocol running keep alive messages back and forth between these two. Maybe if these guys do a static route and this connection actually dies, but the signal stays online because, there's actually many different devices along the way in this path to the customer. And maybe this, this device dies, but this guy doesn't detect it, so he still sees the link up. Well, his static route's going to continue to advertise that. Well, BGP changes that story. BGP has that keep alive where the neighbor relationship fails, and that is really down. So ISP2 will stop advertising that route to the rest of the world. So Fred Newman out here in Michigan trying to access your web server sitting at that corporation won't come in through ISP2 anymore because he's stopped, because he detected that connection was down, because BGP makes it a live connection, right? The second reason I would say we would run BGP is because you have all kinds of metrics that are tied to BGP, to where you can actually make one path into your system look better than the other. I mean, you in reality will end up load balancing. Some traffic will come in through ISP2, and the internet routing table of all the world will determine what stuff ends up there and what stuff ends up here. Well, you can actually influence that decision. There's something known as AS path prepending, where you can make this route look really good through this ISP and not so good through that ISP. So you end up with, just maybe a small spattering of traffic coming in this way and a whole bunch of traffic coming in this way, because maybe you have a faster connection through that direction. And right about there is where I go, we are so far beyond CCNA, but without the why, there's okay, I know how to set up a BGP connection with an ISP router. Check, good job. But it's like you got to have that why. That's why we run BGP in these situations. So now, okay, let's dive into it. Well, let's start off and get oriented on the MAX router. Now, keep in mind, in the real world, you wouldn't normally be able to go beyond the MAX router because the ISP is the ISP. You can't touch their stuff. So I'll do a show IP interface brief. And I see that we've got fast Ethernet 0/0 that has that 63151 address lining up to the subnet that I see there in the upper right of 63150/24, right? And then I've got my WAN link going over to the ISP. Now, one of the things that you'll find with BGP is it's just downright slow. So you want to make sure that you have full connectivity before you do anything. I'm going to say let's make sure that we can ping that ISP router, and we can, and we're good. The reason I mention that is I've gone through the CCIE routing and switching exam, which has a lot of BGP on it, right? And BGP operates so slow. So the CCIE exam, right? You fly out to Cisco, you're in the lab of your dreams for 8 hours where you configure the biggest, wooliest, weirdest network you've ever configured in your life, right? And so you're waiting, you're like, okay, gotta go fast. And BGP takes too long, and you start moving into troubleshooting, and it's just the fact that BGP takes too long. So be used to the fact that BGP takes a while to form neighbor relationships. It takes a while to advertise routes and so on and so forth, right? So yes, we're connected. Now, first objective says we need to configure MAX BGP for the MAX organization in Autonomous System 5000. Okay? Global config mode, router, BGP, and right there we've got our autonomous system number 5000. Hit the enter key. That's now engaged the BGP process in that autonomous system. And your router, just think of it being enveloped. And imagine that cloud just kind of swallowing your router, because it can only be in one autonomous system. If I try to go into another, it's like, nope, sorry, you're in your autonomous system. You're done. And that's all there is to step one, configuring BGP in Autonomous System 5000, right? So now we're going to go into the neighbor relationship, and you're going to find in the realm of BGP, just about every command that you type starts with the word neighbor. Neighbor, you type in the neighbor IP address, and so we say, okay, neighbor 200.1.1.2, that's the ISP. Now check this out. I'm hitting the question mark. And pages of commands that are associated with the neighbor, because that's where BGP does all of its magic. What kind of stuff is in here? It says, well, we can actually shut down that neighbor. And you might say, well, Why would you do that? Why wouldn't you type in no neighbor? Well, that's because it's not uncommon to have a neighbor in here that has, neighbor such and such, this command, neighbor such and such, that command, neighbor such and such, that command. You look at it, you've got passwords, peer group, prefix list, remote AS, remove private AS. You'll have all these commands that are affixed to that neighbor. You don't want to just type in no neighbor and then lose all your configuration associated, right? What if that neighbor just needs to go down for maintenance? Well, then we would type in, well, neighbor, such and such, just shut it down, which means terminate the neighbor relationship, but don't remove all of the commands out of there. Then when you want to power it up again, what do you think you type? No neighbor, shut down, right? So the very first command that we're going to type in here that establishes the neighbor relationship is remote AS. That says, what remote autonomous system number is that guy in? So I'll type in remote AS, hit the question mark, and it says, what is the autonomous system number? And I will say, I forgot, 2500, right? The ISP is running an autonomous system, 2500. Now, before I hit this enter key, I want to highlight the point that this command is how BGP knows what version of BGP to run. Remember I told you there was 2 versions of BGP in the last nugget? iBGP, internal BGP, and eBGP. The eBGP, external BGP. If you type in remote AS and it's the same AS number as you, meaning the one that you specified when you started the process, BGP instinctively knows, that's going to be internal BGP. Whereas in this case, it's a different autonomous system number. BGP then knows, okay, I'm going to run external BGPs. There's different rules that govern those relationships, right? I'll hit the hit the up arrow and cleared what I was typing. Fix that, copy, paste, and we'll do remote AS 2500. Enter key. There we go. So if this were OSPF, boom, neighbor relationship would form, right? There we go. Now, I know you're like, well, that wasn't that long. You're actually right. I was surprised at how fast that came up. It can take anywhere from 5 seconds to 30 seconds for that neighbor relationship to come up. Slow is the word. So before we go any further, I want to show you probably the best show command. Actually, the 2 best show commands ever for BGP. So we're in the point where we're confirming the MAX router is now receiving BGP routes from the ISP. So I'm going to type in 2 show commands. First off, show IP BGP summary. This command is like the show IP interface brief, but for BGP, right? It gives you just the highlights of this, but this is your way of seeing the neighbor relationships concisely. I know if you're thinking of OSPF and EIGRP, you're thinking of, show IP OSPF neighbor, show IP EIGRP neighbor, right? If we type in show IP BGP neighbor, the command exists. It's there, but check this out. We've got one neighbor, right? It's like, I just don't want all of that information. I just want to see the neighbor. Give me the summary of the neighbor. And that's what they give you right here. Show IP BGP summary says, here's some general stuff about BGP running right now, right? And you can peruse through that. But the real meat that I'm looking at is this neighbor. I see version 4, remote autonomous system. This is how many messages received and sent. But where my eyes go to anytime I do this command is right over here. Right-hand side, state/prefix received. So this point is where you will see one of 3 different things. You will see idle. And idle means that the neighbor relationship either hasn't started or isn't going to start, right? Sometimes, for instance, if you type in a neighbor command and that neighbor doesn't exist, it'll sit there and it'll say, well, the neighbor's there. Remember, these neighbors don't discover themselves, right? They don't just like, hello, oh, I found a neighbor, right? No, all neighbors in BGP are statically configured. So if you type in a neighbor and they can't reach that neighbor, it'll just sit there as idle. Now, if you see idle, don't react right away because maybe it's just waiting to start. Remember I said it could take 30 seconds before it decides to start forming that neighbor relationship. So a lot of times you'll see idle and you're like, oh no. You jump in there and try and fix it. The second thing that you might see there is active. And that means it's actively trying to form the neighbor relationship. Don't get the feeling like, oh, active, that's good. That means it's working. No. Usually you'll see if there's a problem, it'll cycle between idle and active. You see, go active, idle, active, idle. I mean, it's trying, it failed. Okay, I'm dropping it. So maybe there's a password on that neighbor that's required and you mismatched the password or something like that. That could happen. What we really want to see is a number. which represents how many prefixes, how many network advertisements we've received from our neighbor. Now, in this case, we received 4 routes from our ISP. Now, if the internet routing table was 4 routes large, that would be a very small internet, right? Jeremy created that ISP, and so he created 4 routes inside of there. But usually, if you are connected to the real BGP, you'll see, 196,000, so, I mean, there'll be some gigantic number of routes that are there. It all depends on what filters the ISP is using as they send you that routing table. Just popped in my head before I forget, when you're done with this nugget, I want you to Google BGP Looking Glass. What that is many ISPs of the world, a lot of times at college universities, sometimes at service providers, will allow you to either via the web page or via a telnet. And I love the ones that let you telnet in. They'll let you telnet into their router into user mode and execute a few commands so that you can see the BGP routing table. The reason that they have BGP looking glasses is because you will want to know, what does my network look like in another part of the world? I mean, I'm advertising this out of Phoenix, Arizona. What does it look like by the time it gets to Japan? Right? What routes are they taking to reach my network? So there's ISPs in Japan. You can actually type in a region. You can say, I want a Michigan or Japan or Asia or China or whatever the case is, BGP Looking Glass, and you'll find sites that allow you to telnet in or via the web page execute commands so that you can see that they are seeing your route over in China, and China goes this direction to reach your network, and then you can tweak and tune and modify. Oh, it's so cool. I'm like, just exploding with information on this. So okay, I've showed you one BGP command, right? That I wanted you to know. Okay, back to the lab. So we see that we've seen 4 prefixes received. Let me show you the other BGP command. It is show IP BGP. Think of this command as the show IP route, but focused in on BGP. So here's what happens. When you are running BGP, you get the internet routing table from multiple sources, especially if you've got a whole bunch of ISPs that you're connected to, right? This guy sends you the whole internet routing table. This guy sends you the whole internet routing table. This guy sends you the whole internet routing table. And it puts it all into that BGP table, that show IP BGP output that you see. Think of this as the holding ground, right? You've got 3 different perspectives on the internet routing table that you just received, and you now have to put them into this holding ground and then choose the best ones of those and put them in the what? Routing table, right? So you've got 3 copies of the internet routing, and now you know why BGP is so resource consuming. 3 copies, if I've got 3 internet service provider uplinks of the internet routing table, and you get to hash through that and choose it. Now, the router maintains those copies in memory. The reason that's good is because that routing table is huge. You don't want to have to keep receiving that from the ISP. Now, what we're seeing here is a very, very small version of the show IP BGP, right? Because I just have 4 routes that ISP is advertising in. Let me show you what it means, and then I want to show you a real view of the show IP BGP. This is the network that the ISP advertised to us. We can see the next hop right there. These are some of the attributes that can be combined together in BGP to calculate the best route. There's actually an attribute called the metric, which is one of the BGP metrics, if that's not confusing, right? It's not the metric, it's just one of them, because another one of them that can factor in is the local preference. Another one that can factor in is the weight. Another one that can factor in is the AS path, the autonomous system path. And so looking at this, I can see this has an AS path of 2500 and then I. What's that mean? I means internal. That means that when I'm looking at this route, I know that it originated from autonomous system 2500. This path is like a passport. As this route passes through different ISPs, they all stamp their autonomous system number on it, like I've been here, I've been here, I've been here. So you can see all the autonomous systems this has come through. When I show you one that's on the real internet, you'll go, oh, okay, I get that. Big important thing is over here, this little caret. That little caret means it has been chosen as the best route. So how connected is the internet? Very connected, right? So you've got this ISP that can reach that 55 network, this ISP that can reach that 55 network, all these different, fully mesh paths out on the internet. So you get, when you receive these routes, different perspectives of ways to reach that. So on the real internet routing table, you would see this network with multiple next hops. You would see instead of this being the next network listed here, there would be a gap. I'll show this to you in a second. And it will choose one of them as the best. So let me show you what a real BGP output looks like. I'm going to do a Google search, BGP looking glass, and we'll say telnet because I want to be able to telnet to it, and I want to be able to execute the show IP BGP command. I know that's a funny search string. It's just I never remember what the name of this website is, and that's it. So notice this is giving us options to go all around the world and telnet into these routers and see what's going on. So let's just grab Telios West. I've set my default telnet application in Chrome to be putty.exe. So I'll open the link and boom. Isn't that cool? Routers around the world allowing you to log into them. Now they'll typically limit the commands that you can do so you don't just bury the router in CPU usage with different commands. But hang on, let me enlarge the font. There we go. Is that better? All right, so I'm going to do a show IP BGP on, hang on, let's just do a summary. They're not going to let us. Let's do a show IP BGP. Okay, now we're talking. Look at this. So we've got these different routes that are being received. Now this, does it have, I think, so this router only has one neighbor, it looks like. That's okay. We'll still be able to see it. So first off, notice I'm pressing the space bar. Hello, internet routing table, right? The one network. And I can see that I've got this one route right here, 1.64.128.0/19. It's being received from this neighbor. Now, here's the AS path. It originated from 4760 autonomous system, and I said that reverse. Autonomous system 4760, right? Then it went to 3791, then it went to 852, and then boom, it landed on this telus.com router right here, right? Now, if we had, hang on, let me see if I can get another router. Oh, wait, hang on. Before I do, I want to show you this. This is an example of AS path prepending. So whoever is advertising the 1.177.0.0 route /21 is actually going in there. Look at the autonomous system over 852 that, before it got to this router, 9318, and then look at this, 3891, 3891, 3890, and 38091. You right? So what? Huh? What? One of the strong metrics, meaning one of the best ways that BGP figures out the best way to reach a network is how short the autonomous system path is. So if somebody has multiple exit points in their network, remember like it was like this, remember? Like when I was showing you right here that you've got a couple ISPs and maybe this one's like, it's not as good. So I want to advertise it so it's there, but I don't want it to look as good. You'll use AS path prepending. So in our case, we would say, let's add 5,000, 5,000, 5,000. Just like he did right here, whoever owns that autonomous system. So this one doesn't look that good, right? So it'll choose a different path if a different path is available. But still, if my primary path goes down, this one, even with all those AS numbers prepended to the end, is better than nothing. Okay, so let's go over to Australia. Right. And see. Okay, good. We've got a router over there. Hang on, font fixed. Okay. So Australia, let's see what you got for me. Show IP BGP. Oh, it's so delicious. Look at this. Perfect example. So same thing, right? Internet routing table. You see a lot of the same routes that are there, but this router actually has multiple neighbors, right? So look at this. So this router out in Sydney, I mean, he's got, looks like on some of these, quite a few neighbors that are coming off here. So let's just take this one right here. 1.0.4.0 /24. He's saying, I heard about that network from this neighbor, this neighbor, this neighbor, and by the way, I applied some dampening to that neighbor. I'm not even gonna go there. Route dampening is what it's called. But down here, I see this neighbor, I see this neighbor. Now look at all of these. They're saying star, 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 meaning they're all valid routes, but I had to choose, and I chose this one, meaning this neighbor. How do I know? Because that little caret right there says that one was the best route. I chose this neighbor, and that is going to be what I ended up putting in my routing table. So you see, BGP, let me do it. Let's see if I can do a show IP route from this guy. So BGP has this holding place that you can see in the show IP BGP. It looks like he's got all of the routing output suppressed. We just see a few static routes in there. So this is probably just a router that somebody brought up so you could see the BGP table from Australia's perspective, but it's not actually using that BGP table to do its routing. But I hope you get the idea. Yeah, I went a little beyond just confirming that we are receiving the BGP routes because I really want you to understand those two commands. Show IP BGP summary, see your neighbors. Show IP BGP, see the BGP routing table. Okay, next step. Advertise the 63.1.5.0/24 network owned by Max via BGP to the ISP router. So let's stop right there. And do that. That's the other big objective that the CCNA wants you to be able to accomplish is how do you advertise those networks? So I'm going to do a show IP interface brief just so I can again see that there's my network. Now, okay, let's go in. Global config mode, router BGP 5000. So the network command for BGP works a little different than the network command for interior routing protocols, right? For IGPs, when you type in, let's just say I'm running OSPF and I type in network, let's just say 200.1.1.0, right? And throw the wildcard mask and everything else. What happens? Two things. One is it says, oh, okay, I'm going to advertise that to other routers. Let's say there's a router over here and everything else that it advertises it to. So that's one thing is it will advertise that. And two, I will start sending hello messages out on that interface so that I can try and form neighbor relationships. Well, right there's something different. BGP doesn't use hello messages to form neighbor relationships, right? It does static neighbor relationships. So right there we know, okay, the network command doesn't do hello messages in BGP. What the network command does for BGP, and I'm going to say this as concisely as I'm humanly able to do. The network command for BGP takes a route from the internal routing table, one that you already know exists, and advertises it into the outside world. I'm going to say that one more time. The network command for BGP takes a route that you already know about in your routing table and advertises it to the outside world. And it is exact because think of what BGP does. BGP says, I'm going to take the networks that you want the world to know about and advertise them out to the ISPs that I'm connected to. So when I type in, if I'm used to the old world of OSPF, RIP, EIGRP, and I type in network 63.000 because it's a class A address, right? I would expect my internal protocols to discover that one and be like, oh, okay, I'm going to advertise that. That won't work for BGP. If you type in network 63.000, it's going to say, okay, do I have the route 63.000 already existing in my routing table? And it would look and it'd go, well, I see one for 63.150, but that's not 63.000. So nope, I don't. I'm not gonna advertise anything. So when I type in the network command for BGP, I have to say network 63.1.5.0 with a subnet mask of 255.255.255.0. Then this one, which is in the routing table. And I know it's a very small routing table right now. I see my BGP routes that I've learned from the ISP right there. But there's my route, 63.1.5.0. It's directly connected on my fast Ethernet 0/0. So to advertise that to a neighbor, I'm going to go into router BGP 5000, and type in network 63.1.5.0 with a mask of 255.255.255.0. I love it. The mystery. What's the backdoor route? So I type that in. I hit the enter key. Now I am advertising that specific network to the world. If I would have typed in network 63.150 and just pressed return, it would not have worked because BGP would say, okay, that's a class A address. So I'm going to assume you're using the class A subnet mask with that, right? In our case, we would say, no. We're actually using the Class C subnet mask applied to a Class A address. We're doing some subnetting there. So I'll drop back and do a show IP BGP. And notice we now have this route in our BGP table. The next hop is our self, and the path is internal only. Now I'm going to do something that only we can do in the lab environment because we have access to the ISP. And I'm going to do a show IP BGP from his perspective. And I see all of those routes that I received, the 55 networks, right, that he's originating. But now he sees, there's the route that I've received from my customer in Autonomous System 5000. Isn't this good? Okay, last two thing. I know I'm going long. It's just it's so meaty in the BGP land. So advertise a summary route 63.2.0.0/16 to the ISP. I even forgot when I read this. This is the Class B MAC address after a hostile takeover of the MIN organization. So it owns this address, but notice it's not assigned to its router anyway. I wanted to show you this because this is done really commonly in the real world. You know, you might have all kinds of little subnets like this all around. Well, one of the things that you'll find is ISPs don't like little subnets. They don't like them at all because it makes their routing table bigger and bigger and bigger. When I did that show IP BGP, I don't know if you noticed, but we're dealing with networks with /19, /22, /20. I mean, big subnets of public addresses. They don't want all these little tiny subnets coming in. And most of the time they'll put a filter that says you're only able to advertise like a Class C or greater. We don't want all of your little stuff trickling in and swamping our router and our routing table. So what people will do is they'll have all these little subnets right there, and they're like, okay, well, I got to advertise a summary route via BGP. So what I'll do is I will create a make-believe route. IP route 63, I forgot it already, 63.2.0.0, 255.255.0.0. It's a make-believe route, and I'm going to send it right out null 0. Right? I'm saying anything that I get for that network, I'm going to send to the trash, because if we really did own that, then we would have all those little subnets behind here, right? And remember the rules of routing, the most specific routes win. So the little subnets, if it received a packet for that, where I said, okay, dump all the trash, all the traffic for that network in the trash, well, it's going to say, well, I'm only going to use that route if these little routes don't exist that can take me a better path, right? And what that does for us is add that route to the routing table. I'm going to do a show IP route, and there it is. And remember what I said the network command does? The network command for BGP takes a route from the routing table. I can type and talk at the same time. I'm amazing myself right now. It takes a route from the routing table and advertises it to BGP. So I'm going to type in network 63.2.0.0, and it's got to match exactly. I see it's a Class B subnet mask 255.255.0.0. Hit the enter key, show IP BGP. And right there, it's now added that to the table. And now if I shoot over to the ISP, again, get his perspective on the story, I can see that right there is that Class B network that was received from the other side. Last objective, configure the ISP to advertise a default route to MACs. See, a lot of times when customers, and I'm giving you a little service provider perspective here, when customers run BGP, they don't really want to receive the routing table of the internet. The main reason customers, meaning the things that CCNA people deal with, run BGP is to advertise their stuff to the rest of the world. They're like, hey, you know, the internet routing table is cool, but I don't want it. Just send me a default route and let me send you my networks to advertise to the rest of the world. So the ISP will do that. They'll put on a filter right here that says, okay, block all routes except for, and let's accomplish that objective right now. Global config mode, route, what am I doing? IP route 0.0.0.0.0.0.0, null. By the way, this is just to give you a little perspective, I get so excited and I have so much fun when I do these configs. This is not how I do it in the real world. Whimsical, woo, let's try this and put this over here. If you're in a data center doing this kind of thing, you've planned this out. You've got the map. You've got your list of commands. You tried it in a lab. You're typing in stuff that you know will work, right? I'm just kind of having fun. So I'm going to go in here and I'm going to do IP route null 0. Okay, now, do you know where I'm going? Router BGP 2500. And I'm going to type in network 0000. See what I'm doing here? Network 0000, mask 0000 to now advertise a default route out to my customers. I'll drop back here to a show IP BGP from the ISP's perspective. There's that default route right there. Shoot on over to Max and do a show IP BGP. And he is now receiving that default route, show IP route, and he is using that default route as his gateway of last resort out to the internet. You see right here. This lab is done. BGP is fun. It is the ultimate box of Legos where you can construct whatever kind of imaginary world you want to with it. Core objectives of CCNA is that you understand how to form that neighbor relationship and how to exchange routes from your system to theirs. You've gotten that and a whole bunch wrapped around it so you understand the big picture concepts of why we're doing that. I hope this has been informative for you, and I'd like to thank you for viewing.